Alright, so in this video you're going to learn about parallel and perpendicular lines. So two equations of a line that we need are going to be slope-intercept and then point-slope form. So hopefully you remember slope-intercept form is y equals mx plus b, where m is your slope and then b is your y-intercept. Point-slope is a little trickier that people forget. It is y minus y1 equals m times x minus x1. Okay, and this y1 and this x1 are just some point that you will be given, and then obviously slope. So to do point-slope form, you need a point, and then you need a slope, okay? All right, so let's take a look at parallel lines. So what is the slope of both of the lines? Notice, again, slope is next to your variable x, so the slope of both lines would be a 4, okay? Will these lines ever cross? No, okay? So what do we call lines that are never going to intersect? We know that from our previous module, they're going to be called parallel. Okay, so therefore, we know that parallel lines are going to have the same slope. So hopefully you remember that from 8th grade or your algebra class, but that is what we know about parallel lines. So now let's look at something else. I'm not going to give it away yet. What observations can you make about the slope of these two lines? Well, we know they are going to intersect, obviously. But there is something special that happens when these intersect, and we know that they form 90-degree angles, okay? And so we call these perpendicular lines. Okay? And what we notice about the slope of perpendicular lines, let's look at these. So I've got a negative 1/2 and a 2. So one is positive and one is negative. So you're going to have that so they can intersect. And then there's also something cool about the fraction. Obviously it's a flipped fraction. So what you would call that is you would say, therefore, perpendicular lines have opposite reciprocal. So they have opposite reciprocal slopes. So opposite obviously means the signs are different. So I've got one positive, one negative. And then a reciprocal is a flipped fraction. So for example, if you had 3/4, the reciprocal of 3/4 would be 4/3. Okay, so you're just trying to flip your fraction. So for example, if you had the number 2, like our top problem, you can always put a number over 1 to then flip it. Okay, but again, they have to be opposite reciprocals, not just reciprocals. All right, so here's some practice. What would be the opposite reciprocal of 3? -3. So again, I can always put that over 1. So then my opposite is going to be a positive number. And then I'm going to flip that fraction 1/3. So if you're trying to find a perpendicular slope, you would have to do opposite and then flip your fraction. So same thing if you had a 4th and you were looking for the opposite reciprocal to make it perpendicular. It's going to be a negative number. It'll be -4/1, which would just be a -4. So again, that is how you find perpendicular slopes, is by taking the opposite reciprocal. All right. So why don't you try this page on your own? So I want you to tell me whether they are parallel, perpendicular, or neither. So kind of give me some justification why you guys think that as well, okay? So press pause and try these on your own. Really press pause. Talk about what we got. For the first one, I got neither, because if you look at your slope, you had a -3 and a -2. They didn't have anything in common, and they were both negative, so that's going to be neither. And you can tell by looking at the picture. In the middle one, we had to do some math and look at our rise over run with our slope. So the slope of this line going up was up 3/1, and then the slope of this line going down was -1/3, and I know -1/3 and 3 are perpendicular, so I said the lines would be perpendicular because their slopes are opposite reciprocals. So that's what I want if you guys are justifying on a quiz or a test. Over here, they were parallel because their slopes are the same. All right, on the bottom part, obviously this first one is parallel. You've got same slope, right here, this is where they're going to try and trick you. So they forgot to flip the fraction, okay? So if this was a -1/5, then it would be perpendicular, okay? But they forgot to flip the fraction. Right here, they would be perpendicular because their slopes are opposite reciprocals. And then this last one, they are going to be parallel, okay? All right, so I hope if you have any questions on that, let me know. Otherwise, we're going to look at some points now. So are the given points parallel, perpendicular, or neither? Okay, you need a lovely formula to find the slope of these lines. And that formula is going to be y2 minus y1 over x2 minus x1. Okay, so let's do that together. So here's my x1, my y1 point, x2 and a y2 point. So when you substitute that in, you would have 9 minus -1, and then 5 minus 0. So again, two negatives are going to give a positive. So I've got 10 over 5, which gives me a 2. Okay. Now I'm going to do the same thing for this point, x1, y1, x2, y2. Plug it in the formula, 1 minus 3, 4 minus 0. So 1 minus 3 is -2 over 4. I can reduce that fraction by dividing it by 2. So I get -1/2. Okay? So what do I notice about 2 and -1/2? I notice that those are opposite reciprocals, so those would be perpendicular. Okay? If I would have gotten 2 for this second one over here, then they would have been parallel. And if I would have gotten any other number besides that, that would have been neither. Okay? So again, if they give you 2 points, you're going to have to do one more step and find the slope, and then kind of compare those two slopes. All right, let's move on. So I'm going to do one, and then you're going to do one of these on your own. So the question says, write the slope-intercept form, okay? And I know that's y equals mx plus b of a line parallel to this line. Oops. Through this point, okay? So first off, if it's going to be parallel, I know it's going to have the same slope. So I know my slope is going to be a 2, okay? Nextly, so I know a slope, and I have a point. So guess what? I need to use point-slope form first, which is y minus y1 equals m times x minus x1. So if I plug in my slope and I plug in my point, that'll give me half of my equation, okay? So I'm going to start off with y minus 5, because that's my y point, and this is going to be my x point, equals my slope, which was 2, times x minus my x point, which is a 2. Okay, so we're almost done. The only thing wrong with this is it's not in slope-intercept form, which is y equals mx plus b. So to get y by itself, I'm going to have to do some math and distribute this out. So I would get 2x minus 4 equals, bring down y minus 5. Lastly, to get y by itself, I'm going to add 5. And I'm going to do it to its like term over here. So I would get y equals 2x plus 1. Okay, so that is the equation of a line that is parallel to this one going through this point over here, okay? So if you got a sheet of graph paper out and graphed both of these lines, you would see that they're parallel and going through this point. But that is how you find something parallel to a point. So why don't you try this one on your own? Press pause, and then I will show you guys what I got. So on this bottom one, you're finding a line that's parallel. So you had to use the slope of a -3. And then here's your point. So you're going to plug it into point slope form first. I got y minus 4 equals -3 times x minus 1. When you distribute, don't forget that a negative times a negative is a positive. So then you should have gotten -3x plus 7, okay? All right, if you got a question, let me know. Otherwise, we're going to move on to perpendicular, okay? So these are set up the exact same way, except you're going to find something perpendicular. So my slope is a 2. So if I'm going to find the opposite reciprocal, I'm going to make it negative and then a fraction, okay? So this is my slope now, and here is my point. So I'm going to start off with y minus 3 equals my slope times x minus my x point, which was a 4. Again, you're going to distribute and get negative 1/2 x. Negative times a negative is a positive, and half of 4 is a 2. Equals y minus 3. Lastly, I'm going to add 3 to its like term. So y would equal negative 1/2 x plus a 5. Okay? So again, if we graph this, and I graphed both of my lines, whoop, we could see that they would look parallel. They would look like they form a 90-degree angle. Okay? All right, why don't you guys try this one down here? Again, you're finding perpendicular to this line through that point. All right, so for my answer, perpendicular to 2/3 would be negative 3/2. Again, put it in point slope form first. Notice here when it's x minus negative 2, that will become a positive. So once you distribute out, negative 3/2 times 2, again, remember if you've got a number in the numerator and denominator, those will cancel out, so it was just a negative 3. Again, I can teach you how to do that in the calculator if you need some help with fractions. Lastly, add 6 to both sides, and you should have gotten negative 3/2x plus 3. Okay? So if you've got any questions on how to write something perpendicular or parallel through another point, let me know. Otherwise, we got one more problem by myself and then on your own. Okay, so they've given us a line shown in the graph. Use the grid to graph a line that goes through this point and is parallel to the line shown. And then we're going to graph our line. So I have a point. The only thing I'm missing is slope. So what I'm going to have to do is find the slope of this graph. So again, slope is rise over run. So draw your little slope triangle. I went down 2 over 4. So my slope will be negative 4/2, or just say negative 1/2. And since we are graphing parallel, I can go ahead and use that negative 1/2. So go ahead and plug it into point slope form. So y minus negative 5 equals my slope, x minus negative 1. Again, 2 negatives are going to give you a positive. So you would get negative 1/2 x minus 1/2 equals y plus 5. Subtract 5. So y is going to equal negative 1/2 x minus, we can go ahead and make that 5.5. Okay? All right, so if I were to graph that, it'd be a little bit trickier. But I would start at negative 5.5 and then go up 1/2. Oop, just kidding, down 1/2. Hold on. Parallel, we're good. Okay. Down 1/2, down 1/2, down 1/2, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. And we should notice that that line is going to be parallel. It's never going to intersect. Okay? Alrighty. So I want you guys to try the last one on your own, but make sure you read the directions because it says perpendicular. Press pause. Right, so first off you had to find the slope of this line, which was the exact same, and it was negative 1/2. So again, if you're finding something perpendicular, you're going to have to use the opposite reciprocal, which was a 2. Once you plug it into point slope form, those 2 negatives will become positives, distribute, subtract, and you get 2x minus 3. So I started at negative 3, and went up 2/1 and kept going. Great thing is it intersected, up 2/1 and continued. Again, if you need to go down and left, you're going to do the opposite. So that looks like a perpendicular line. It looks like it formed a 90-degree angle. Okay? All right, to practice. IXL is lovely on your IXL paper. It's kind of down here. It's E5 and E6. We're going to get to these later on. And then if you do need some extra practice, there's a coordinate plane review if you need practice on slope of a line or if you need help on equations of lines. All right, but go ahead and get started on your practice.